Hey there! What if I told you I could mathematically take this orange, split it up into a finite number of pieces, and put it together to create two of the same orange? Welcome to the Banach-Tarski Paradox. First, let's take a closer look at this orange.
It has a finite number of atoms in a crystalline structure, meaning that if you were to look at this orange in a microscope, you would see the atoms laid out in a fixed pattern. Now, let's split up the atoms into four groups, R1, R2, R3, and R4, and spread out the atoms so that each group is no longer a solid.
The pattern the atoms are in is the same as it was originally, just spread out. Nothing else has changed.
If we rotate R1 by some angle and put it together with R2 in the same spherical region,
the atoms in both groups line up, forming the same crystalline structure as the original orange.
Assume we can do the same with R3 and R4, and what we are left with are two oranges the same size as the original, but with half the density.
It is impossible to create two objects from one with the same density as the original because objects in the physical world have a finite number of atoms or points. It is for this reason that Banach-Tarski is just a paradox. However, this paradox can exist mathematically. The difference between math and the real world is that math does not have to follow conservation of mass. A sphere, like an orange, does not have a mass. It is just an uncountable set of points with a particular collection of topological and geometric relationships. Let's take a look at an infinite set of natural numbers.
There are the same number of even numbers as even and odd numbers. That might sound crazy, but the set of all whole numbers is just denser than the even numbers. If you match every even number with a whole number, you will never run out of numbers from either set. Therefore, both end up being the same size. In simpler terms, if you divide infinity by 2, you still have infinity. If you do the exact same thing with the odd numbers, you end up with two sets of numbers that are the exact same size as the original.
If we go back to the orange from before and pretend it has an infinite number of atoms and we split it up into a finite number of pieces, say 5, we won't have to spread out those atoms because 5 divided by infinity is still infinity. We are no longer dealing with the problems that comes along with a finite group of numbers. And when we are done, what we are left with are two oranges with the exact same density, size, shape, everything as the original. And that, friends, is the Banach-Tarski Paradox. Thanks for watching.